Hey everybody, welcome back. Today we are going to be talking about our second section of chapter 1. We're on 1.2 already. We're just moving, we're grooving. We're going to be talking about inductive reasoning today. So when we look at inductive reasoning, we are going to be also making conjectures. So today our objective is going to be to use inductive reasoning to make conjectures. We are going to have 3 vocabulary words today. We're going to have conjecture, inductive reasoning, and a counterexample. And on the next slide, we get to find out what they are. Alright, looking at this slide, you will notice we have that wonderful yellow bar right there. So please write that down right now. Okay, so a conjecture. Conjecture is an unproven statement that is based on a pattern or observation. So if you look at, let's say the pattern of 1, 3, 5, 7, ... Looking at that pattern, you could make a few conjectures. One conjecture, you could say, well, I'm just going up by odd numbers. Or another conjecture being, well, I'm just adding 2 to the previous number. I'd be adding 2 here. And you could make a conjecture and basically an educated guess as to, all right, well, this I'm going to be adding to. My next numbers will be 9, 11, 13, and so on and so forth. When we start looking at these conjectures and looking for these patterns and making those conjectures, it is known as the process of inductive reasoning. All right. A counterexample, and that's a big word there, counterexample is an example that shows a conjecture false. So when we somehow make, there's a statement out there, and we want to make sure that statement is not always true, we find a counterexample to show that the conjecture is false. So this is key. Please write these down, and I'll go over them. Okay, a conjecture is considered false if it is not always true. So if you look at a conjecture and it is 99 times out of 100 true, okay, if it is 99 out of 100, it is almost always true, it is still false. If you can find one counterexample, you prove the entire conjecture false, as you can see in that next note. One counterexample proves the entire thing false. All right, let's look at a couple examples. So looking at this, you don't have to write this down. I'm just going to go through this quickly so you have an idea of what it is. So this one says complete the following conjecture based on the examples. So if I look at this conjecture, okay, I look at it and I say the sum of any 2 odd numbers is, and I'm looking for my answer. What goes into that blank? All right, well, let's look at it. Sum of any 2 numbers. Sum meaning we're going to be adding. So if I look at 1 plus 1, that equals 2. If I look at 3 plus 3, that equals 6. 5 plus 5, that equals 10. What if I just did 3 plus 7? That's also 10. So if I look at this, I have odd plus an odd, odd plus an odd, odd plus an odd, so on and so forth. I'm looking at the numbers that I am coming up with. It appears that the sum of any 2 odd numbers, when adding those 2 together, my answer is always going to be even. Try to come up with some other examples. 9 plus 3 is 12. There's another even. 11 plus 33 equals 44. Another even. So it appears that the conjecture should be the sum of any 2 odd numbers is even. All right? Let's write a couple of examples down. Please write this down and see if you can come up with the proper ending to this conjecture. Look at some examples. Give it a shot. Alright, so the conjecture on this one says the product of any 2 odd numbers is, and again, you're going to be looking at that word. What does the word product mean? It's talking about the operation of multiplication. So I'm going to be multiplying 2 odd numbers. Alright, if I take 3 times 3, 9. What if I take 7 times 5? 35. Alright, what if I take 11 times, well, let's say 1? 11. Okay? Notice what happens in each one of my answers, they are turning out to be odd. This one is going to be odd. Okay, I notice that every single time I multiply two odd numbers, my answer is odd. All right, give it a shot in a couple more. 11 times 9, 99. 3 times 7, 21. You could go for bigger numbers, but why not stick with the smaller numbers that we know the answers right away? All right. Next conjecture. This one, you're going to show the conjecture is false by finding a counterexample. So on this one, you're gonna read the conjecture and come up with a way that we can prove that it is false. This conjecture is not true. Come up with a way to find that to be false. Pause and give it a shot. Alright, so this conjecture says the sum of two numbers is always greater than the larger of the two numbers. Okay, so if I'm looking at this, I'm looking at two numbers. 3 plus 8. Okay, 3 plus 8 is 11. Okay, the sum of two numbers is always greater, so the sum, it says the sum is greater than the larger of these two numbers here. So is 11 greater than 8? Yes, it is. All right, so that didn't disprove it. Let's look at 4 plus 15. 4 plus 15 is 19. Okay, so I notice 19. Is 19 bigger than one of these two numbers? Or the larger of the two? Yeah, 19 is bigger than 15. So that doesn't prove it. Neither one of these do. But what is an example or a counterexample that makes it false? Look at your number of 0 plus 3. What is 0 plus 3? It's 3. So the conjecture says the sum of the two numbers is always, that's your key, always greater than the larger of the two. My sum here between 0 and 3 is 3. Is 3 larger than 3? No, they're the exact same. This says always, and 3 is equal to 3. So if you add 0 to any number, that disproves that conjecture. It is a counterexample. Give this one a shot. It's the last note of the day. Give this one a try and see how we come up with it. Alright, so notice the conjecture. It says all shapes with four sides the same length are squares. The same length are squares. Okay? Can you think of a shape that has the exact same length but is not a square? First of all, what is a square? It is a four-sided figure, all sides the same, and all angles the exact same measure of 90 degrees. So is there a shape that has four sides with the exact same length? Yes, there is. If you came up with an example of a rhombus is the counterexample of this conjecture. It tells us that each one of those sides are the exact same, but notice the angles. The angles are not the exact same. Okay? And because of that, those angles not being the exact same means it is not a square. So I have all the four sides the same length, the angles are not, so that is my counterexample. It's going to be a rhombus. Alright? That's all I have for you today. Good luck on the homework tomorrow. Enjoy.